Hello, here's an example of a consumer surplus problem. So we have two price functions here. One is the supply function and the other is the demand function. And we need to find, first of all, the equilibrium point between those two functions. So to do that, we can just set them equal to each other, or you can look on a graph and see where the intersection point is from the graph. Sometimes that can be really difficult to get the exact point. So sometimes the algebra is easier, but certainly if the algebra is complicated, it's easier to just look on the graph. So you can choose on that what you want to do. Here, these are very easy to put set equal to each other. So that's what I did. Just set those two equal to each other, solve for x. So the x value of that point is 260. We need to find the both the x and the y value in this case. So we're going to put it in either equation. I chose to put it in the demand equation and just find the y value that goes with that 260. So that's how we find the equilibrium point. Let's take a look at the graph now. So you can see we've got both of these things graphed at this point, and we're looking for the consumer surplus, which is above the rectangle. So what rectangle am I talking about? There's not one on the screen. Well, it's the rectangle that's formed from the equilibrium point. So if you drop a line down from the equilibrium point, straight down and straight back to the y-axis as well, you have a rectangle there. So that's the rectangle I'm talking about. We're trying to find the area between the shaded area. So if you look at my little hand drawings there, they show you what we're doing in terms of finding the area between those two. They're not curves, but curves. So we've got the top of the area, and then we're going to have to subtract off the area of the rectangle to get rid of that section. And then we'll have the shaded area, and that shaded area is the consumer surplus. So let's do the integration. Here is the formula for consumer surplus, and you're just going to take that demand function. In this case, we're calling it f of x here, but it's the demand function. So you need to make sure that you've got the demand function in there and not the supply function. And you're going from 0 to the equilibrium point. The P1, X1, that is the equilibrium point, is the XY coordinates of that point, and that is the height times the width of that rectangle we were talking about. So the integral is the area underneath the top function, and we're subtracting off the area of the integral of the rectangle. We don't need an integral to find the area of the rectangle because it's just width times height. So plugging the numbers in and our function in, we end up with this integral to do, and it's not a very difficult one. So we end up with a consumer surplus of $3,380. So that's the amount of money that the producer could have gotten with the higher prices. That's it. Thank you.